Okay, everybody. We're going to take just a half a step back right now and think about the topic of derivatives. We spent a good chunk of time earlier this week working on derivatives and definition and how to work out that four-step process and do all that by hand. You will have to do that in your homework by hand. You will have to do that. Show me the step-by-step process on a test. In fact, we're even going to have a hand written quiz where you have to show me that. I haven't assigned it yet, but it'll be coming your way. So you're going to have to do that. Okay. But the truth of the matter is that most of the time, whenever mathematicians need to take a derivative, whenever your business professors need to take a derivative for some kind of maximizing this or minimizing that, whenever they do that, they're probably not doing it by the definition. Okay. It just takes too long. And luckily for us, what we find is there are some basic properties that happen whenever we're looking at certain kinds of functions. And there are some shortcuts that were found by some mathematicians many, many years ago, like we're talking 1700s. Okay, so hundreds of years ago, some people took some really valuable time and figured out, hey, there are some shortcuts for some of these things we're doing over and over and over again. They saw the patterns, and thankfully for us, they put it down so that we can use them. Okay, so real quickly, a notation just because I want you to be all up on it. So f prime of x, we've got that guy. Okay, that means derivative, right? But there's a little bit of other notation that you see sometimes. Dy dx, okay? This is the derivative of y with respect to x is what we say. We use this whenever we've got, as most of our things are, a variable in the function that is x, or d dx f of x. You might see it like that. And this is just the derivative of your function, again, with respect to x, where x is my variable. Okay. All of these represent the derivative of the function f at x. Okay, so you might see this in different ways, written in the homework, in the book, those kinds of things. I just want you to know that that's out there. Okay, so without further delay, here are some of our shortcuts. Okay, here's a rule. Okay, mark it down, put it somewhere. It's on a formula sheet probably. The constant function rule. Constant function rule. Okay. And this is what it says. If your function y equals f of x equals some constant c, and then, again, mathematicians, sometimes we're not very creative. C stands for constant. Then we know the arrow means then. Okay. F prime of x equals 0. Okay. Period. Done. Okay. So, in other words, if you start out with a function that is just some constant, what's a constant? Constant is any number, no variables. Okay. So, if you start out with some constant as your function, you automatically know you don't have to think about it. You don't have to work on it. You don't have to do any definitions. You know your derivative is going to be 0. Okay. So, what does that look like? Okay, if f of x equals 3, this is part A. If f of x equals 3, then, and I tell you that, then you're going to tell me my derivative f prime of x equals 0. Done. Okay. The idea here, and we'll get to it a little bit later, I'll actually explain it to you after we have the power rule here in a minute. But the idea here is that certain things happen every time there's a constant that makes this be 0. Okay. It just You don't have to think about it, okay? So, I will from here on out, we're gonna talk a lot about derivatives, and I will say, "Okay, what about this 3?" And you'll say, "That's a 0. Ignore it." Okay? So, and that's what we should do. Okay? Find y prime for y equals negative 1.4. That's part B. Find y prime for y equals negative 1.4. And you're going to tell me y prime is 0, Dr. Webster. That's what you say, right? Oh, that's a constant, 1.4, negative 1.4. That's just a constant. There's no variable attached to it. We don't have to worry about it. That guy's a 0. Okay? So, real quickly in the same line, I want you to find dy dx of negative pi. Okay. And it shouldn't take you this long. Hopefully you already got it. Okay. Dy dx just means find the derivative. Negative pi. What's pi? 3.1415926. Yes. Okay. Pi is a number, negative 3.14 here. Then all you have to say is, oops, that's a 0. I'm not going to hassle with it. I'm not going to mess with it. Dr. Webster, don't try to trick us here. It's just a 0. So that's the really nice one. Okay. Anytime you see a constant, that guy's going to be 0. Okay. Moving on. Here's a rule. Okay. And we don't have tons and tons of rules, but here we go. This one's called the power rule. This one we use all the time. Okay. So you're going to get really used to this. If f of x equals x to some exponent, we're calling it n, where n is a number, okay? Technically, n is a real number, okay? So it can't be imaginary, is what we're saying, but it can be any other number. Then it is a power function. Okay. It is a power function. Okay. That's what we know. That's what a power function is. Okay. So your rule goes like this. If y equals f of x equals x to the n. Oh, I'm sorry. Let me start over. It's because I'm out of space and I was trying to cram it. Okay. Sorry. Here's your rule. If y equals f of x equals x to some power n, where n is a real number, then let me make that the same n I started with. Then we know f prime of n equals, I'm sorry, f prime of x equals n times x to the n minus 1. Okay. So what the heck are you telling me? Okay. We started out with x to some power. What we do is we take that exponent, we write it down in front, we multiply that times the variable, and on the exponent, instead of writing n up there, we write n minus 1. Okay, that's what we do. Okay, so let's try another one. Okay, y prime. Well, y prime is the same thing. It's just based off of the y here, right? N times x to the n minus 1. Same thing. Okay. There's another way you might see it written. What is it? So there's this guy. There's this guy. These are the same stuff. dy dx, right? And it looks exactly the same. N times x to the n minus 1. Okay. It all works out the same way. Absolutely. So, in fact, you can do this. These are the same. Okay. There's your rule. Okay, so what are we going to do? We're going to pull the exponent down. We're going to write it out in front. We're going to multiply. And once we have multiplied, then we will subtract 1 from the exponent to get our new exponent. All right. So, question. Okay. You're given f of x equals x to the third and told to find f prime of x. Okay. Look at this guy right here and tell me if he is a power rule, if he is a power function. X to the third. We got some variable, it's being raised to a power. That's not an imaginary number, it's a real number. 3 is a real number. So can we use our power rule here? Yes. Here for this one? I hear yes in my head. Okay, so very quickly, we're going to use our power rule. So f prime of x equals, take your exponent, write it in front, 3 times, make it into multiplication, x to the, and I'm going to write it here, 3 minus 1, but I won't always do that. So whatever your exponent was, minus 1, 3x, what's 3 minus 1? To the second power, 3x squared, right? Okay. That's how that power rule works. It actually, once you use it 2 or 3 times, you start getting a flow for it. You'll be like, oh, this is amazing. I got this. Okay. So here's another example. F of x equals x to the 1/2. Okay. Stop for a second and ask yourself, is that a power function? Is my variable being raised to some exponent and it's a real number? So, in other words, is 1/2 a real number? Yes. Okay. So real numbers include whole numbers, counting numbers, integers, negative numbers, fractions, decimals, even square roots of 3. Okay. Weird irrational numbers will be okay here. Negatives are okay. Fractions are okay. All those are okay. All right. So they all work the same exact way. Only thing you can't have up there and use this power rule on is if you had an imaginary number. Okay, so no imaginary numbers. Everything else works. Okay, so what's the rule? Take your exponent, write it out front, 1/2 times x, write your variable, don't forget him, and then subtract 1 from your exponent. Now be careful here. You can do this. If you need to, you can do it on a calculator. This is 1/2 times x to the, what's a half minus 1? If you need to, you can say a half minus 2 over 2, right? It's a negative 1/2. All right. So yes, you're going to have to deal with negative exponents. That's okay. We're not stressed about them. Yes, we're going to have to deal with fraction exponents. It doesn't matter. We're just going to use this rule. It's going to be all right. All right, so here's an example. Once I write it, push pause and see if you can do it on your own. F of x equals x to the 1/4. Find f prime of x. Okay, so in my head, I hear you saying, I hope you're doing it. Take the 1/4, write it out in front, 1/4 x to the 1/4 minus 1. You're going to be careful with that exponent. That's 1/4 minus 4 over 4. That's what a 1 looks like with a 4 on the bottom. That becomes negative, x, negative 3/4. 1/4 times x to the negative 3/4. That's it. Okay. Do another one. I want to do another fraction one so that we can all do it. F of x equals x to the 3/2. Find the derivative. Like I said, once you practice with these multiple times, hopefully you're getting good at them. F prime of x equals 3 halves times x to the, it's 3 halves minus 1. Be careful with this because 3 halves is a fraction, but it's a fraction bigger than 1. So the other ones where I had a fraction less than 1, when I subtracted 1, I got a negative number, right? 1/4 was less than 1. When I subtracted 1, I get a negative number. 3 halves is actually 1 1/2, right? So when I subtract 1 off, I get a 0.5 or a 1/2. Okay. So just watch yourself. Make sure you know, oh, I can't do that. I gotta be careful with whether or not it's bigger than 1 or not, whether it's gonna be a negative, but that's it. You're good. Okay. Here's a slightly different problem. F of x equals x to the negative 3. Find f prime of x. Okay, how is this different? Now we have a negative exponent to begin with. Oh. But the process is still the same. That rule is not going to change. So f prime of x equals, bring the negative 3 down, multiply it by x, subtract 1 from the exponent. Be careful here because what's negative 3 minus 1? Negative 3 minus 1. Negative 4, Dr. Webster. Yep. Okay. So you have to be careful. You have to know those integer rules. You have to be good with your arithmetic or use your calculator to punch in minus 3 minus 1. Okay. So if you need to do that, then do that. It's okay. These are the types of things you're working on here. Okay. Here's you another one of those. Example. After I write it, push pause and work it for yourself. What if f of x is x to the negative 10? Find f prime of x. Okay, you're going to see me kind of start shortcutting it a little bit. I'll pull this down in front and I'll write minus 1 there so we know we need to do that. Just because I don't want to have to write it every time, but hopefully if you did it properly, you've got negative 10 times the x to the negative 11, right? Because you subtracted 1. Negative 10 minus 1 is negative 11. Hopefully you did that all right. Okay. How about this one? This one you're going to have to think a tiny bit. Okay. This actually leads us to the problem that we did last time. Let's just do 1 over x. Okay. Last time we did this by hand and it was kind of a long thing. Find f prime of x. Here we're going to find, there's lots of ways to do this one. There's something called a quotient rule. We'll get that later. But what we're going to find is knowing your exponent rules. Didn't I tell you to know your exponent rules? I know I did. Okay. Knowing your exponent rules here is going to pay off for you because we're going to rewrite this. Okay. F of x equals, we're not taking the derivative yet. We're just rewriting the original function. Okay. What does it mean when x is on the bottom? That means that if I want to put it on the top, that makes it a negative exponent, right? Those negative exponents, x to the negative 1, that's what made us move that to the bottom to begin with because mathematicians don't normally like leaving things as negative exponents, okay? Now, you just did a couple of problems where we had a negative exponent. You pulled it down, subtracted 1, pulled it down, subtracted 1. You're okay with that. But here's what's going to happen. We're going to see some as you work through your homework, and you're going to say, hey, that x is on the bottom. I don't like him being on the bottom. I'm going to rewrite him on the top. And whatever his exponent is, I'm going to give him a negative exponent. And that is a perfectly legitimate rewrite question. Okay, rewrite ability. And then you're going to go, oop, I'm going to use my shortcut. Negative 1 times x to the negative 1 minus 1. That's a negative 2. Now, if you don't like this, okay, and you're like, I don't like the way that looks, I want to put that back on the bottom, that is perfectly legitimate, okay? This negative exponent can be written on the bottom, right? So I can move it to the bottom. Negative 1 over x squared. By the way, these things up here could have been written with on the bottom, right? This could have been negative 3 over x to the, when I move this to the bottom, it changes the sign on that exponent, right? Makes it positive. This is negative 10 over x to the positive 11th. Same thing's going on here. We got negative 1 x to the negative 2, but if we want positive exponents, we can move it to the bottom. So remember that that negative exponent rule thing works both ways. And if we don't want to leave this as a fraction, we want to use this power rule shortcut, we absolutely can, because we're going to rearrange it. Okay, so do one real quickly. F of x equals 4 over x to the third. I want you to rewrite it first and then find f prime of x. And by the way, I'm saying f prime of x, it could be any function. It could be g prime. It could be whatever. And the variable could be any variable, x, y, z, t, whatever it is. Okay. So pause for a second, rewrite, and then find your f prime. Rewriting it. F of x equals 4x to the negative third, right? The rewrite is moving that guy to the top so that it's not in a fraction form anymore. Instead, we have a negative exponent. That's your rewrite. Okay. Then you're going to use your power rule. F prime of x equals, be careful with this, negative 3 out in front of this is 4 x to the negative 3 minus 1. I just kind of skipped a little step. We'll see that rule in a second, but you'll get there. Because I'm just pulling this out in the front and multiplying, right? So I think it's a natural follow. But if you don't like it, hold on a minute. I'll get you the form, the rule. Okay, so negative 3 times 4, that's a negative 12. X to the, we're subtracting 1 from the exponent. It's x to the negative fourth. Or if you don't like that, negative 12 over x to the fourth. You can always rearrange these so that you got a positive exponent. And on my math lab, I would say just really, really read the rules, read what they're saying, their directions on a problem. Okay. All right. There's a couple of other exponent rules we need to deal with. Okay. So that last function, or that last property, we had f of x equals, let's say 3. Okay, that's a constant, and we got a shortcut rule. We said, oh, that's a 0. The derivative of that is a 0. Absolutely. Okay, but why does that work? Okay, that's what I want to get at here. What's really happening here is the 3 is a number. All of the other power rules that we have x raised to some exponent up here, right? Okay. This one, the x has gone away. Okay. The reason for that, we could actually write x to the 0. We could always write that. It's like when you have something times x squared or x squared sitting there, you can always write a 1 out in front of it, right? 1x squared is the same as x squared. Okay, so what I'm saying here is 3 is the same as 3 times x to the 0. Because what is the exponent rule? Hopefully you remember. Anything raised to the 0 power is a 1, right? Anything raised to the 0 power is a 1. So that would just be 3 times 1. So that doesn't change this value. Okay. So technically, what we're doing with the constant rule is a shortcut of a shortcut. Because if I went to go take this derivative, f prime of x equals, I would pull this exponent down times the 3. That would be x to the negative 1. Who cares about that? Because out here in the very, very front, we're multiplying by 0, right? And what do we know about multiplying by 0? Anything multiplied by 0 is a 0, right? Okay. So that shortcut rule for constants is actually a shortcut of this power rule. It's just that we give it first because we're like, oh, look, we actually already know that guy. Okay. Any constant is a 0. No problem. Okay. Some other exponent rule. Now you see why I was like, know your exponent rules, know your exponent rules, because it comes back to haunt us right here when we start dealing with derivatives. Okay, if f of x equals square root of x, then find f prime of x. Okay. Again, we're going to rewrite these guys. Again, I look and I see, oh, that's one of my problem children, right? I can't divide by 0 and I can't take the square root of a negative number. So those two, whenever I see fractions and whenever I see radicals, I go, oop, there's probably a problem. Okay. So somewhere in your exponent rules, there's a rule that says how you can rearrange something that looks like a radical. Okay. And I tell my students whenever I teach this level of exponent rule, I learned this from a GA of ours. So the exponents always, I can always have a 1. The square root, the root there is a 2, but this will work with any root. We'll see that in a second. Okay. So when I used to work with a certain GA, she said exponent rules are like flower power. Okay. Okay. Whenever we have a flower, the power is always in the petals, right? Okay, up on top. That's what everybody likes to look at, right? That's the pretty part. The power of the flower is in the petals because they look so beautiful. Okay. And that's what we see above the ground. Okay. Here's the ground. Okay. But what's down here on the bottom is the roots, right? The roots. And that's what brings the water up and the nutrients up and allows the flower to be so pretty. The roots aren't so pretty, okay? They're not where the power is, but they are definitely a very, very important part, right? Okay. So when I look at this radical here, here is my power, and here is my root, okay? And these guys can be rewritten as the power divided by the root. Okay. Now, if you absolutely hate what I just said and you're like, I'm not going to do any stupid flower power thing, that's okay. You don't have to do any stupid flower power thing. I don't care. Okay. But you need to remember some way for you to rewrite this sucker. Okay. So f of x, if it equals the square root of x, where the square root is a 2, you need to know I can rewrite this x to the power goes on top, 1 over the root goes on the bottom, 2. Okay. So this is the same as. These are the same thing. They're a different way to rearrange it, rewrite it using the rules that I know about my exponents. Okay. So when you do that, you're going to be able to rearrange this guy. So if you have another way of thinking of this, a different mnemonic, anything like that, I don't care. Okay. You can use any way you want to, but be able to rearrange this. Okay. Now that I have it rewritten as this, we actually already did this problem earlier, right? It looks like a power function now, doesn't it? Some variable raised to a power. Yeah, we did this earlier. F prime of x equals, take this exponent out in front, 1/2 x, subtract 1 from the exponent, it's to the negative 1/2. We already did that problem. We just didn't know necessarily that it came from a radical. And it absolutely does. It comes from a radical. You got to be able to rearrange those. Okay. So that's why I've been harping on you. All these exponent rules that are coming to play now, we needed them for exponential functions, we needed them for logarithms, and we need them for our derivatives. Okay. All right. So don't let them, fool you or whatever. We got to do this stuff. Okay. So here, you do one. Here's an example of f of x equals the third root of u squared. I want you to find f prime of x, but I want you to rewrite it first. Anytime you see these fraction things, anytime you see these square root things, radical things, cube root in this case, you're going to rewrite it first. So push pause, figure it out. Okay, so hopefully you push pause. We're going to rewrite this guy, f of x equals, and this, I'm so sorry. If it's going to be a u, it should be a u, right? Okay. So all of these should be u's instead of x's. I think I threw that in going, let's make it a u so it's not always an x. And then I habitually forgot about the x. I'm sorry. So don't let that throw you. That was an accident. That's a typo on my part. Okay. A handwritten typo. All right. Rewrite this. F of u is u to the power is 2, the root is 3. So you can rewrite this u to the 2/3. That's your fraction. Okay. Once you have it rewritten, I expect everybody can probably use your power rule by now. Maybe you need a little bit of work with it, but you take that exponent, you put it down in front. There's my 2/3. You subtract 1 from this and be careful about it because 2/3 minus 1 is a negative 1/3, right? Okay. There you go. Okay. So there is a look at the power rule, just using the power rule over and over, where the two special guys you're going to work on, okay, because we did some of these earlier, right? When I first put out the power rule, okay, we did stuff and you were fine with it. X to the 1/2, got it. X to the 1/4, got it. X to the 3/2, got it. Okay, so it's not the fact that it's a fraction in the exponent, I hope. I hope that you just think, oh, I need to learn how to rearrange this. Once you rearrange it, you can do that. We also did the other one earlier where it was x to the negative 3, x to the negative 10. That came from the negative exponent came from it looking like a fraction to begin with, right? So those two weird guys, just know they're out there. Yes, they're going to be on your homework. Yes, they're going to be hanging out. Yes, you're going to see them on a test. All right. We have another rule. Okay. If y equals k times some function. Okay. This is one, I actually just did this one a minute ago. I did it early. I'm sorry. I put a 4 in here, right? And we had some 4 was a constant times x to the negative 3. And I just said, oh, we're just going to multiply it. I kind of hand waved that. But now we have a rule. Okay. If you have some constant k that is multiplied out in front, it's not a big deal. Y prime equals multiply that k out in front and then find your derivative of your function, okay, which is exactly what we did earlier. This is called the constant multiple rule or property. And it just means, hey, we're going to take these derivatives exactly like we've been taking these derivatives, but we are absolutely just, if we have a multiple out there, a constant number, we're just going to multiply it. So if f of x equals 3x squared, okay, then my derivative is, leave the 3 out there. It's going to be multiplied. This is a power function, right? Do my exponent rule times 2, x to the, subtract 1 from that exponent. It's a first, okay? And then at the end, I do need to clean this up, okay? You can't leave it 3 times 2 times x to the first. This needs to be what? 6x, right? Absolutely. Okay. You can do 3 times 2. That's not a difficult portion of this particular thing that we're doing. All right. Here's another one. If y equals t to the third over 6. Don't freak out about this one. Okay. Do I need to move this to the top like I did earlier? The answer is no. The reason why is because this is a constant. When did I move it to the top? When it was a variable on the bottom. Yes, when there's a variable on the bottom, you need to take that guy and move him to the top. This is not. If you would like to rearrange this before we go anywhere, you can say this is the same as 1/6 times t to the third. Okay, so if you want to, otherwise you can just keep that 6 on the bottom. It's fine. We only have to rearrange it when it's a variable on the bottom. Okay, so now I've got some number sitting out there in front, 1/6. I don't care. I'm going to pull my 3 down because that's my exponent. Write my t, and then use your exponent rule. Subtract 1. 3 minus 1 is 2. Okay. This is the same as 3 over 1, right? So this is 3 over 6 in front. And hey, look, we can reduce that. 1/2 t squared. Absolutely. All right. So just having a little constant out in front, don't let it throw us for a loop. We're just going to multiply. It's okay. That's multiplied. The 1/6 is being multiplied by the t to the third. The 3 was being multiplied by the x squared. We're just going to keep on doing that. So don't let it freak you out in any way. Okay, so you do one. F of x equals 4x to the fifth. Then you should know f prime is what? Push pause if you need to. 4 times, bring down the 5, x to the, subtract 1 from your exponent, right? So 4 times 5 is 20, x to the fourth. There you have it. Okay. Let's do one that's just a tiny bit more complicated. What if y equals 1 over 3x cubed? I highly recommend, because I see that x cubed on the bottom, I'm going to rewrite it first. Okay, and when I do that, I'm going to write this 1/3 as if it's a fraction out in front. And how do I bring this x to the third to the top? What's the exponent rule? That's really x to the what? -3. Yep, make it negative, move it to the top. Okay. Again, this is not taking the derivative. This is rearranging before I can take the derivative. This is putting it into a nice, pretty format that makes it to where I can actually do the math, right? So the 1/3 sitting out in front, what y prime is, pull your -3 out there times -3. I'm going to write this over 1 just because I know I've got a fraction I'm going to have to deal with. Okay. X to the, what's the exponent rule? Subtract 1. -3 minus 1 gives me a -4. And then, like I said, I am going to clean this up just a tiny bit. It was a -3 there, so this is a -3 that I multiplied out in front, but it was times a +1/3. The 3's are going to go away, but that negative, it's going to stick around, right? So if you need to, you can write -1 x to the -4th, if that helps, or just negative x to the -4th. Either one of those, that's cleaned up. That's just perfect. No problem. Okay. All right. On your very own, push pause. If f of x equals 0.9 over the cubed root of x, this one's a little bit more complicated because, find f prime of x, because it's got a radical and the radicals in the denominator. So you're going to have to use both of your properties. So I'm going to pause. I'm going to work it myself. You should pause and work it yourself and then come back and see. Okay, so I rewrote it twice. Okay, the first thing I did was make that radical in the bottom. It's a 1/3 power. Okay, so I rearranged it so that instead of a radical, it had a fraction exponent. And then the second rewrite I did was to move this to the top. So it makes it a -1/3. Okay, then I applied my power rule. Okay, so the 0.9 times the -1/3, subtract 1 from the exponent. I made the 1 into 3/3. That makes my new exponent -4/3. Okay. I did go ahead and multiply these, and my calculator tells me it's a -0.03 x to the -4/3. I am perfectly happy if you leave it like that. However, I have noticed as I teach derivatives that sometimes students want to make things do more simplifying or whatever. If you want to, you could make it like this, where the 3 goes, the 1/3 is on the bottom. Or there's one more way that you could simplify this, and that would be to put, well, two more ways actually. The x to the 4/3 back on bottom. Okay, because I want to make it into an instead of a negative exponent, you can move that whole thing down to the bottom. Okay, and the last thing, some people even like to do this 0.9 over -3 is to make this back into a radical, cubed root of x to the 4th. Okay. I don't need you to do any of these steps. Okay. These simplification steps, these rearranging. Some people really want it because they don't like the fraction. Some people really don't like the negative exponent. I'm okay. And if you put any of those on a test or on your quiz, they're all correct. However, I would just stop here. Okay. I think sometimes the fewer steps you take, the better it is because the less likely you are to make some silly mistake as you're working through. So I'm okay with this -0.03. I'm not okay with this 0.09 times -1/3. You can simplify that a little bit. So go ahead and do that. If you left it like this, you'd probably lose 1 point on a test. So it's not a huge amount, but those 1 points do add up. This is what for sure I wanted to see. And then if you did any of these other simplifications, the problem is you could lose points if you mess up in that, right? So I just say leave it alone. Leave it alone. You'll be okay. All right. So, I believe we have one more real quick shortcut rule that we're going to fit in for this, and then you'll be able to do this homework. So the last one is, it's called the sum and difference property. Sum and difference property. And this one is so very, very useful to us. We'll actually go back and look at something we did before. What it says is if f of x equals u of x plus or minus, meaning it could be plus or it could be minus, either one, v of x. Okay, what do you think these guys are? Some little function, right? Okay, so then you can take the derivative of the whole thing by taking the derivative of the smaller things and adding them. Okay. So the rule kind of looks a little bit crazy, but what does it really mean? What it means is whenever I have a great polynomial, okay, you have something that looks like g of x equals 3x squared plus 2x. And they want me to find g prime of x. Okay. When I see something like that, I say, hey, this is its own little thing, power rule, power function that I could take the derivative of, and this is its own little thing. Okay. So isn't it u of x, this guy, plus v of x, this guy? Yes. So the sum and difference property says you can take the derivative by taking the derivative of this guy. So 2 times 3 is 6x to the 2 minus 1 is 1. Hopefully you're getting that fast with it. You don't have to write it all out over and over again. Plus, use the sign that's in the original function. What's the exponent on this guy? 1. 1 times 2 is 2. Be careful with this guy. X to the 1 minus 1. I'm going to write it down. X to the 0. What is x to the 0? We talked about that earlier. Anything to the 0 power is a 1. So this is just 6x plus 2. Okay. Cool. So I can do combinations of different little polynomials, little things like that. So you can try it. If f of x equals 8x minus 2x squared, find f prime of x. And hopefully you very quickly can say, well, that's, multiply that down. 8x to the 0, that's a 1, minus 4x to the first. I don't have to write that guy, right? So that makes it easy for me to come up with. Okay, do another one of those. Let's do one we did by hand. We actually did this one by hand last time, but it's the one that I told you to work on your own. So let's do one we did together by hand last time. Remember how long it took us to do these things? The problem was y equals 4x minus x squared. And just as a reminder, we used the 4-step process. Find IROC. We did all this stuff. It took us a long time. Step 3, step 4, and we finally ended up with 4 plus 2x. Okay, there's where we did the other one by hand, but I sent that one for you to do on your own. Okay, so 4 plus 2x. Let's do this using our shortcut real quickly. This is a 1. So y prime equals 4 times 1 is 1. I'm sorry, 4 times 1 is 4. We're going to subtract 1. That becomes x to the 0. That goes away. You'll get used to seeing, oh, there's just a constant in front of x to the first. Basically, the x is going to drop out, and you just get the constant dropped out. Okay. Minus 2x to the first. We don't care about that x to the first. Look at that. We did it in one quick step. That's the same answer we had, 4 plus 2x, right? 4 plus 2x. Oh, I'm sorry. Apparently, the last time it was a minus sign. Oh, oh. Actually, I think y'all let me get away with making a mistake in that last one. Hang on a second. Let me look for it. Sure enough, I apologize. I distributed this negative sign through on the last one, and I didn't put my negative there. And from there on out, everything's a mess on that one term, right? I'm so sorry. If y'all saw that when you were watching that video, I apologize for making a mess. Oh. So it was 4 minus 2x. I'm sorry about that. I'll try to put a little notation on that other video. I'm not going to redo the video, but dang it. So this is actually nice. The shortcut, I didn't make a mistake. And then the one by hand, I did. So there you go. So we can see where this is very valuable to us, right? Let's do one more. I'm going to give you one for you to work on. F of x equals 4 plus 2x to the third minus 3x to the negative 1. Okay, I think you can do it very quickly, hopefully. Here's one that has the 4 in there as a constant. What do we think about that constant? What's the derivative of a constant? 0. So you can just write the 0 or you can just ignore that guy, okay? 3 times 2, this is 6x squared. Let's subtract 1. And then be careful here. Negative 1 times negative 3 is a positive 3. X to the, this is negative 1 minus 2. X to the negative 2, right? Absolutely. All right. So you can do some of those. I'm so sorry. I made a mistake in that other video. That's really going to bug me. I'm going to have to go back and look at it. I don't want to remake that whole video, though. Okay. So maybe I'll put a note about where the mistake is. All right. Just real quickly, there is something that we're going to learn later in a couple of more sections called a quotient rule. The directions might say something like find the derivative of f of x equals 1 plus x squared over x to the fourth. In a little bit, I actually might get to where in a couple of sections where I might just do this as a quotient rule, but we don't know the quotient rule right now. So that becomes kind of a problem. But we do know some stuff about what we can do whenever we have a fraction with a variable on the bottom. We can move that to the top. So before I work this one, I'm going to rewrite it. Okay. F of x equals, and I'm just going to say 1 plus x squared because it's times the whole entire top, right? Times x to the fourth. Also, there's going to be a product rule later when we multiply things, but we still don't know that. So I'm going to rewrite this again because the nice thing here is it's just one term being multiplied through, right? So I can distribute that, which makes my life a lot easier. X to the fourth times 1 is x to the fourth, plus x squared times x to the fourth is x to the sixth. Oh, look, that's a nice, pretty polynomial. I can for sure take that derivative. Now I can find it very easily. 4x to the third plus, oops, y'all almost let me do it again. It's a negative. Let's try again. I'm sorry. I must be getting tired. When I moved it to the top, I made it x to the negative 4, right? Okay. Got to move it and make the exponent negative. So x to the negative fourth times a 1 is x to the negative fourth. But let me start this guy over. It'll be prettier. Let me start it over. I'm sorry. Find the derivative. Sorry, I was just getting tired and I was in a rush and I wanted to move on. Find the derivative of f of x equals 1 plus x squared over x to the fourth. My rewrite looks like this. Sorry. 1 plus x squared times x to the negative fourth. So move that to the top. And then I'm going to rewrite it again by distributing. X to the negative fourth times a 1 is x to the negative fourth. But then it's plus. Be careful with this guy. I'm multiplying, so I add, but one's a negative and one's a positive. So the rule for adding integers is when you have different signs, you subtract them. So it's x to the 4 minus 2 is 2, and you take the sign of the bigger number, right? So if you wanted to, you could punch that on your calculator. -4 plus 2 gives me a -2 there. All right, now we can take the derivative of that guy. That was my original function, right? So the derivative would be -4 x to the subtract 1, -5. Be careful because when I pull this guy down, okay, the sign goes with him. So this is -2 times a positive. So minus 2x, subtract 1 to the -3. There we go. All right. So that's the kind of problem you're going to look at. There are some word problems on this homework set, so you might have to come up with some of that, but I feel like we're probably pretty good on the word problems. I might make a separate video on those if I feel like I need to. All right. Thank you. Let me know if you have questions about the homework.